Hi, I'm Michael Toporek. I'm managing partner of Brookstone Partners. I'm sitting here with John Belizaire, the CEO of Soluna.
Michael, good to see you.
And the genesis of this discussion is really around a lunch that John and I had a while back when he was explaining the ins and outs of how blockchain and the sort of cryptography really work. And I found the way he described that very illuminating and something that I haven't read, that I haven't seen before, that when I finally heard it, it clicked in my brain. And so we thought it would be a good idea to take a kernel of that lunch and really expose that in a more formal way so that everybody has the benefit of that sort of lucid explanation. So what I'd like to do today really is sit down with John and get that more formal exposition of blockchain, Soluna, what the company does, why it's actually so different in its approach relative to other companies in the space, and then more generally for the investor community, understanding how Soluna intends to provide a return to its investors.
Right.
So with that said, John, I'll begin with the obvious question.
This is going to be fun. You know, Michael, the
Fun-
last
more
time
fun for
you
me than
started
you.
asking me questions, I mean, I thought I was going to die. It was like hours.
That's true.
So I'm looking forward to it.
So are you ready
Hopefully
for
I'll be able
the
to satisfy.
first obvious question?
Yes.
What's blockchain?
What is blockchain? So blockchain is the underlying technology to cryptocurrencies. More formally, it's what powers Bitcoin.
Great. So what
But
does
actually
what does that mean?
What's more interesting to me, I'm a technologist, I'm a geek, and I wanted to get to the bottom of really what this thing is before I obviously got involved in the project. And I think the best way to understand what blockchain is, it's the solution to a set of problems that this Satoshi Nakamoto person had to solve for, right? And there were three primary things that creating this new money that Satoshi was trying to create, he had to solve some real challenging problems, right? So the explanation I always give folks, and the example you showed during that lunch, is I start with just a simple conversation that people can think about, and that is around this concept. Suppose you want to run a bank.
Okay.
And today we understand the concept of a bank. You go to a bank, you deposit your money, and the bank keeps tabs on all the transactions that you make around that money. You send money to your friends, you take money out, that sort of thing, all of those sort of concepts. And that's stored on a central ledger at the bank.
Yes.
Somebody is writing something in a book somewhere about all the transactions that John makes, Michael makes, and hopefully those transactions are not nefarious in nature. And everything's fine. But let's suppose, for example, that this bank was no longer trustworthy and you had to recreate the bank without that central ledger.
Okay.
And so that's the first thing Satoshi had to solve for is how do we create a distributed ledger that doesn't have to be stored by a single entity. So no central ledger. The second problem they had to solve for is, well, if there's no distributed ledger and there's no central entity, that means that all the participants, so let's suppose we're a set of friends and we want to create this new bank that doesn't have a central ledger. We're the ledger. The participants in this bank, we're the ledger. So you had to create this peer-to-peer network where we're all managing this
What does that
ledger.
mean, we're the ledger?
We are essentially all participating in this bank, and we all have a sheet of paper in front of us, let's say. And every transaction that occurs between each of us,
Yes.
we're each going to write down that transaction.
So let me be clear. So if you trade with Joe,
Yeah,
I got to write it down too, even though I'm not involved.
correct.
Okay.
Because we all want to keep track of what's happening, and we don't want to have a single person responsible for keeping track of what's
So
happening.
before, the bank kept the ledger
There's only
for
one.
everybody.
There's only one ledger, and it's managed by the bank, and we trust the bank, and so the bank is keeping the ledger, and they're responsible for keeping track of all of those transactions. But let's suppose we didn't trust the bank any longer. We're creating our own bank,
Okay.
and we have to manage all the transactions. Well, we can't just give it to Joe and say, hey, you keep track of all the transactions.
Why can't
We
I just
trust
say,
you.
we all trust you, John? You just keep it
because
for
you're
us.
basically back to the beginning again. You're back
Okay.
to this central ledger.
Okay.
And so the first goal was essentially eliminate the middleman. So disintermediate the need for a central ledger by having everybody keep the ledger. And so in our little club here, our little banking club, we each have a sheet of paper, and we're going to start writing down the transactions that happen between us. So I send money to Joe. I sent $5 to Joe. We all write down John sent $5 to Joe. First, we check that John actually has the $5 because we communicate how much money we have to each other, and we start this process of doing this. And so far, everything's working pretty well because we all trust each other. We keep track of all of these transactions.
Yeah, but what if I'm lazy and I forgot to write something down?
Well, we communicate where everything should be, and we sort of check to make sure that you wrote down hey, you got the transactions all wrong. Like fix it.
So
why are you so lazy?
You check with me before.
Yeah. Okay. In our we haven't gotten to blockchain yet, but in our little club here, let's say that we're doing that.
Okay.
And so far, that's working. That's working pretty well.
All right.
And that's based on the fundamental assumption that all the members of our club are trustworthy, and we trust that we're going to write down the transactions, and we can see each other and write down. But what if we were not able to trust each other? In fact, what if we wanted to make trust irrelevant in the construction of this new bank? We would have to create a system such that, number one, we make sure that we write down all the transactions. We make sure that we keep track of all the transactions in a way that it's very clear where the ownership has changed hands. So that's one of the things that Satoshi had to solve for.
Okay.
He not only had to create a ledger, but he had to create a ledger such that it accurately stores the movement of an asset through its life. So it's always clear who owns that asset. Okay. And then the other thing we had to solve for is we had to create a way to maintain the integrity of this decentralized ledger, this ledger that we all keep track of. Those three fundamental things are essentially solved by the technology that we now know as blockchain. Okay?
How?
So once you solve that, you essentially have the foundation for creating lots of things, and primarily.
But how is that solved? I guess.
Let's talk about. I'm gonna walk you through.
Okay.
So those are the three problems you have to solve. So let's go through each of the problems. So now we know that we're keeping track, and we're keeping track of our transactions on this page. But now suppose, for example, that we don't trust each other. Okay, so what we want to do is we're going to create a system such that the trust...
And the reason we wouldn't trust each other is because we start out with an investment club of 5 people. We all like each other.
Yeah.
But now all of a sudden, there are 200 of us, and
right.
I don't really know everybody.
In fact, I don't even know how big the club's going to be. If you compare it to a peer-to-peer network that everybody knows, at some point there was this network called Napster, and the same model. Everybody had a list of all the songs that were available on the Napster network. There was this notion everybody trusts each other. So if you went to get the song was actually there. Mm-hmm. But Napster, to some extent, sort of had this decentralized ledger of the songs, if you will, and everybody had to have the songs. But you had to register with Napster that, hey, I'm joining this network,
right.
and so Napster knew who all its members were and everything.
Okay.
In our bank, we don't necessarily require that. In fact, we want the bank to be global. We want multiple participants, and it can be as big as we want.
Okay.
And so at the heart of that, we don't necessarily want to require ourselves to trust each other. In fact, we really want to make trust irrelevant, because if you can make trust irrelevant, then you don't ever need a single trusted party. You can make the entire system work from a decentralized way. So here's how it works. So now let's go back to our scenario. We're all writing the transactions. I send money to Joe. Mike sends money to Phil. We're all writing down the transaction. At some point, as I said, we're writing down the transactions on a sheet of paper. In fact, I got a sheet of paper right here. I can demonstrate, right? So I've got a sheet of paper. We're all writing down our transactions on the sheet of paper.
Okay.
At some point, that sheet of paper is going to become full of those transactions.
Okay.
Right? And we have to all agree that, okay, we're done. These are the transactions that have taken place in the time that we've been writing the transactions down.
Okay.
And at some point, we're going to have to validate those transactions and then essentially put them in a permanent record of the transaction.
So this isn't real time. This is batch processing. So you wrote down a whole bunch of things.
That's right.
And you didn't even verify that John or Phil even had the money.
We did do all that verification along the way. Yeah.
Okay.
So we have the ability to see, hey, John has this much money. He can actually verifiably do that. And we write the transaction down and so forth.
Okay.
And we're doing that along the way.
All right.
But at some point, we need to protect the integrity. Remember, I talked about the integrity of this ledger. This is one piece of the ledger, so we have to protect that So think of it this way. At some point, we need to sort of lock in these transactions such that they can't be changed anymore.
Okay.
And then we need to put it someplace where we can go back and look at it anytime in the future and know what occurred in the past.
And the we is who? Just you and me, or
yes.
anybody in the
any
whole network?
members of the network? Yes, any peer.
So from that perspective, it's very transparent.
Correct.
Okay.
And we're going to put this piece of paper, let's say, in a folder, and we're going to try to keep the pages sequential in the order that the transactions took place.
Okay.
So in the folder, the pages are the blocks.
Okay.
And the set of pages in the folder become the chain of information that we're constructing as part of it. That's the blockchain fundamentally.
Okay.
Now, let's talk about maintaining the integrity of the sheets and then eventually the integrity of the chain itself.
Okay.
Now let's talk, we're going to protect the sheets. How do you protect the integrity of a page, okay, of transactions where no one, again, is trustworthy, right? How would you go about doing that? That's the fundamental problem that Satoshi had to solve for.
Encryption is
exactly
the way the banks do it.
So everybody does. Yeah, so they encrypt the sheet.
But how can you encrypt it and let everybody see it at the same time?
Exactly. So that's one aspect that you have to solve for, and you want to do it in a way such that it can never be tampered with. In fact, it should be designed such that if there is any tampering, it's instantly noticeable.
Okay.
So I want to pause the conversation for a second and have you imagine that we had this thing over here called the magic machine.
Okay. I like magic. Magic
machine, yes. So this machine is magical in that it has the following properties. So if you take the sheet of paper and you put it through the machine, it will translate that piece of paper into a single number that's always the same length.
Like a Rosetta Stone.
I guess. Rosetta Stone changes into languages, right?
Right, one language
to another. So this changes any set of text or any information, no matter how long it is, it always turns it into a single number.
So the same text generates the same number, no matter what.
Correct. And that's another property. So you can put it through the machine 100 times, it always gives you the same number. It's always the same length. Okay. The other property that it has is if I give you the number.
So there's like a little mathematical equation that takes all that, puts into
it's
something. It's
magical, yes. But yes, it is magical.
But can I reverse engineer that? Can I test?
Good question.
Can I put if I put a sheet with an A in the middle, and it's like, oh, then I can with brute force test a lot of things and kind of figure out how to.
The answer is no. So if I give you the number.
Yes.
If I give you that number, there is no way for you to.
What if you gave me the number on the page?
Surmise what was on the page.
But what if I had 100,000 or 1,000,000 pages and 1,000,000 of the numbers?
Yes.
Can I put that through some sort of magic box decoder and figure out what's in the magic box?
The answer is no. So the machine only works one way. So that's the other property. So the sheet goes one way, you get the number. You can't put the number back. It would be nice, but no, it doesn't
can't
work.
Put the number at the machine.
Yes, exactly.
Got it.
So imagine that magic machine existed for a moment. And the other key thing about it is sometimes when you put the page through, it actually the number's always the same size, and sometimes it has some zeros in front, so it's always the same length. Okay. And the other property is if I change a single thing on the sheet of paper, it will produce a new number. Okay.
Yes, I understand.
So now you understand how the magic machine works.
Yep.
So what we're going to do with that sheet of paper that holds all the transactions, we're going to use the magic machine essentially to protect the page such that we know when it's ever been changed. Okay. Because we know if you change the number, if you change the page, there'll be a new number. So how do we do that? So we take the page and we ask ourselves the following question. Okay. What number that when I put the page, if I put that number on the page, on the sheet, and I put it through my magic machine, produces a number outside the other side of that magic machine that starts with 3 zeros. That's the puzzle that we need to solve.
I'm a concrete guy. So this thing, pretend we're going to work in less digits than I know the whole thing works.
Sure, no problem.
We're going to put this through the magic machine.
Yep.
We get numbers 4, 5, 6.
Right.
4, 5, 6, 7. Got 4. And you're telling me that what number do we have to put on this page so that we don't get 4, 5, 6, 7, so that we get 000, 4, 5, 6, 7?
Correct. Yes.
Okay.
Oh, it starts with 3 zeros. How would you solve that puzzle?
I would, by brute force, by keep putting pages in until I get something that does that, then I'd realize how the page was altered so that what the alterations I needed to put on the page until I found the 3 digits.
That magic number.
It
Exactly.
would take me a long time.
Yes, exactly. And depending on how much information is on the page and whatnot, you basically have to guess, essentially.
Correct. A lot of
there's no
guessing.
way. Because you can only use the machine one way.
Right.
So you would take the page, try different numbers starting with 0 to infinity, presumably. Potentially rather, and as soon as you found a number that produced the 3 zeros, you'd stop.
Yes, because that was my goal.
Exactly.
Okay.
So now here's the trick to our integrity problem.
Yes.
So by finding that number that
Okay.
you're going to use once,
Yes.
also known as a nonce, you're going to write that page that number on the page, and then you put it through the machine, and it produces the number with 3 zeros. Okay.
Got it.
Then what you're going to do is you're going to announce to the rest of the group that you found that number. And
Why do I want to find this number? I don't understand. Why do I want to find the 3 zeros on top?
We'll talk about that in a minute. But what
Okay.
we're trying to do is to seal this page with a number that ensures that nothing has been changed on the page.
Okay.
Okay, before we put it into the folder.
Okay.
And you know nothing has been changed on the page because you know that if something has been changed on the page, there'll be a different number that appears on the other side of the magic machine.
That's right.
Right?
Okay. Yep.
So the nonce is just a way to ensure that we all have the same page. Let's think
Okay.
through that for a second. So if I come up with a nonce that's 000, that's a nonce that says 1, 2, 3, 4 is a number that I add to this page. And if I put it through there, it creates a number with 3 zeros. And I give it to you, another member of the network, and you do the same thing. That means that the information on your page
Is the same as mine.
Exactly.
Perfect.
So we want to make sure that all the transactions that are on the sheets are exactly the same between all of us before we stick it into the folder and seal that page. So now we know.
But how do you get that page to everybody in the network?
Everybody already has a copy because everybody was writing down the
So
transactions.
they wrote down. Everyone writes down the transactions all at the same time.
That's right.
And
then we all performed a magic machine exercise.
yes.
Right.
So I got my
And
4, 5, 6, 7.
the first one to find the correct page, the correct nonce rather.
And now, why am I doing the nonce thing? That's what I don't understand.
You're doing the nonce because we want to find a number
yes.
to seal the page such that this page is locked.
How does the nonce seal the page?
The way the nonce seals the page is if this nonce, if you, let's say you do 1, 2, 3, 4, and you say 1, 2, 3, 4 is
1, 2, 3, 4 in the lower right hand corner.
Is the lower right hand corner is what produces my
the triple zero.
The triple
and then
zero.
4, 5, 6, 7.
Right.
All right.
That means that everything that was on the page before I put the 1, 2, 3, 4,
Yes.
right, is what creates that triple zero because I combine what's on the page with the nonce and it comes out the other side, right?
Okay.
Now suppose one member of the team decides that, well, I'm going to change one of those transactions on that page, and it's going to be a different transaction, but I'm going to keep the nonce the same, okay? And I'm going to put that in. I'm going to put that page in my folder. Well, if you take his page and you put it through the magic machine, it will not produce. So now I just want to seal this page. I want to make sure this page is protected. The nonce seals that page for me. Now, let's say, for example, we put all these pages in. They're all sealed. Nobody touched them.
Okay.
And one of us, call him Bill, one member of the team, he decides that I'm going to go back a few pages and I'm going to change some transactions. I'm going to have Mike send some money to me.
Okay.
Right? And and the page is already sealed, so nobody's going to look at it. And so I could actually change history and have money come back to me by changing the record. Because
Okay.
you want to look at the record and see who owns what and so forth, remember, right?
Yes.
So how do you protect that from happening? Okay. So you want the blockchain to be designed such that not only is each page sealed, but the entire chain is sealed
So
in some
when
way.
people talk about like a currency being hacked,
Right.
like the Neo being hacked, like these new currencies, cryptocurrency, is this how they hack it? Someone goes back into the record and says, "No, this money's mine."
So the headlines you see are the cryptocurrency exchanges that are moving those currencies around being hacked.
Okay.
And the networks themselves that are being hacked, there's an attempt to make changes. Yes, attack the network in a way that benefits one of the members of the network.
Ah, okay.
Yes. And so continuing with this conversation, I'll tell you how to bring it all together. So we started out with we're all trusting each other, we're all writing it down. Then we said we don't trust each other. We're going to protect each of those pages.
Okay.
I want to take it one step further. We don't trust each other. We want to protect the entire history. We want to protect the whole folder.
Okay.
And the way to do that is going back to our magic machine now.
Yes.
what I want to do is I want to say, what if I want to change a record that's in the past, remember? So what I want to do is change the exercise now, the puzzle that you have to solve. And I want to change the puzzle to be the following. What number would you have to come up with, the nonce, right? Such that when you put it through the magic machine, along with the magic number from the previous page. Let me let that sink in for a second.
Yeah, no, okay. So what number would I have to put in from...
So I have to put the number, the page, and the number from the previous page.
Yes.
All through the magic machine.
And what am I going to...
I need to get 3 zeros out the other side again.
How am I going to get 3 zeros? Like, how do you know 3 zeros is going to come out?
You don't know, but you have to try.
But what if they don't come out?
They'll come out. Because mathematically speaking, there is one point where a number gets created that there's 3 zeros, because that's how this magic machine works. And by the way, it's probably a good time to introduce you the real name of the magic machine. It's called the SHA-256 hashing algorithm. It is cryptology based. And fundamentally, it takes information from any size, of any size. It performs a host of different mathematical functions on it and produces one number on the other end. So mathematically, there's a scenario where you can multiply different numbers, add them, divide them, such that there's 3 zeros in between. Okay. So that's going to happen. But to solve that problem, it's a much harder problem, isn't it? Mm-hmm. So now you got to find this nonce. That's the question mark.
But I know the nonce. I mean...
now
I just look at the nonce?
Now the nonce is my first scenario was I'm just protecting the pages, but now I've got to build a system that protects the whole chain. So my nonce question is the real nonce question that actually gets asked to protect the whole chain, and that is, give me the nonce such that I combine it with the page and the hash value, okay, the magic number, fingerprint number from the previous page, such that when you combine all of those
hash
three...
value, that's the 4, 5, 6, 7.
Yes, from the previous page.
From the previous page.
Right? So now you're going to put the previous page, the current page's hash, and the nonce, which you're trying to guess, such that you get 3 zeros on the other end. First of all, that's going to take you a lot longer.
Right.
But it has this very interesting property, and that is the fact that you put the hash from the previous page, if there's ever a change to any of the pages, well, first of all, now, are you with me with the...
I'm here.
Okay. And because they're all connected, okay, because the calculation is connected and takes into account a previous page, okay?
That's like the chain. You got the block, and the chain is connecting the numbers between the blocks.
Exactly, that's right. So by doing that, you essentially create a system that protects its integrity, because if I change one page, it breaks all the nonces.
Right, because all of
a
sudden
single
nothing
page
works.
Right. And you know what you would have to do if you really wanted to tamper with the system? You would have to go back. Let's say you went back 15 pages back, and that's the page you're making the change.
Right.
You would have to go back and recalculate all the nonces across the entire set of pages. For the previous 14, let's say, for example.
That's a lot of computing power. But
correct.
Some people might have that kind of computing power.
Right. It's true. So so let's pause for a second, right?
But forget bank.
Yeah.
We've created a way to keep track of a series of any kinds of transactions.
That's right. That's the beauty. You're with me already. And by the way, every time I do this over cocktails or whatever, the same thing happens, because they're like, oh, but those transactions could have been anything. Correct. So to me, this is what gives me goosebumps when I really dig into blockchain, and that is, and you haven't even asked me, like, who does all these perform these transactions.
I'm not even there yet.
But what really gives me goosebumps is, if this really works, then what Satoshi really created in the process of trying to create his little digital currency or digital money is he created for the first time a decentralized peer-to-peer network that can manage any asset in a highly secure way. I call it the
it's secure and public.
It's secure and transparent. That's right. And so
that's the two sides of that coin.
That's right. And
because to make something secure, you could just go like this, and it's secure, but no one can see it or use it.
Yeah. And so what he's done is he's combined distributed ledger technology, which is not unique. He's combined it with cryptology, which is not unique, and he's combined it with peer-to-peer networking. So he's taken all of the components of technology and created something unique, which is a distributed integrity platform.
So I'm going to get back to a question I wrote down when we first started talking.
Okay.
Why do I want a distributed ledger? That's because we started out with this. So I think I know the answer, but I want to hear it from you. In that this bank or the centralized authority or whoever it is keeps all the transactions in one spot.
That's right.
So why do I need all of this?
You're absolutely right. So here's the thing that hit me right like when it you keep
this is
studying
cool,
this stuff.
It's interesting.
It's cool, interesting, but
why?
But it kind of hits you in the head. It's like, wait a second, like this is a way to create and manage digital assets. And the question is, like, what else is a digital asset? Well, things that you don't think about that are generating billions of dollars right now are digital assets. I give you a simple example: your identity, your medical records, the property records that are kept all around the world for all different transactions. Those things today are pieces of information, bits and bytes that are stored in central ledgers. They exist happily in those central ledgers and so forth. But there's some real problems that arise when you try to move that information, or you try to protect and maintain and secure that information, because by the very nature of the fact that it's centralized, it becomes under attack, because that asset and that information has value to it because of its existence. So take very large credit card companies that keeps all sorts of information about us in a centralized fashion. They're attacked all the time. The time.
What's interesting to me, John, when I was reading the Financial Times in the past several months, and I was right after Equifax and whatever got hacked for the 15th time, and 200 million people's credit information got stolen. And it was an editorial, and the guy said, why aren't they required to keep all that on the blockchain? And he used a term I'd heard before, but it really resounded to me, in that Equifax keeps all its stuff in, I'm not going to say one spot, since it's probably in multiple places, but for all intents and purposes, one spot under their umbrella.
Right.
That's a honeypot that says,
that's right,
all that good stuff is sitting here.
Right.
And so then he made the case that the more distributed it is, so they hack John Belizaire's piece of the blockchain. That's a lot of energy to decode all that. And what are they going to get? One John Belizaire's credit info?
Right.
That's just not worth it.
That's right.
How does... It's nice for me to say, like, as a layman, but how do you take something like Equifax and put it on the blockchain? I read it. I said, yeah, sounds good. But I'm thinking to myself, what are you, dumb? Yeah, it sounds good. Well, does he really understand how to? It's nice to say conceptually, but can it really be done?
Well, nothing we talked about prevented us, limited us to this just being about, tracking transactions, about money that's moved around. And by the way, money is a pretty valuable thing. If we can do it for a bank, credit card transactions is probably not that hard, right? We're just talking about you're performing these transactions, and we're keeping track of them on the
But
blockchain.
how do I keep because now with this whole Facebook thing exploding,
right?
Saying,
so that was
personal
another example
information everywhere. So
yeah.
How do I keep my personal information on the blockchain so it's secure and so I can share it with somebody else? So
That's a great
how
question.
does that happen?
So let's assume for the moment that everything we talked about, these technological advances that have been brought together to create this blockchain platform, let's say, that's kind of the low-level stuff that's happening in the network. I liken it to the bits and bytes that move across the internet that you don't pay attention to anymore because you're just checking your feed on Facebook.
I was going to date myself and say it's like the old-fashioned assembler code versus programming in a higher language.
Right, exactly. It's your TCP/IP network, because we're talking about networks here. So what you're going to see is, because people are beginning to realize the real potential of this, like I said, like you can manage any asset around this platform, you can start building applications and interfaces that a person can use and start storing your information through those interfaces. And underneath, it's stored and transacted and protected and secured on that network.
Okay, so I'm ready. Where's my Facebook? Where's my credit report on
They're
the blockchain?
They're coming. You're starting to see, hundreds and thousands of new projects and very bright people being attracted to this whole
without getting
space.
Overly technical.
Yeah.
How am I going to do that in there? I don't make the connection to me from my credit report, my credit information put on the blockchain, so that when I give somebody permission to pull my credit report, they can look at it. And also, if I don't pay my bills, somebody can appropriately ding me and lower my credit rating.
Right.
I mean,
Right.
how do all these people
the way
get,
to think about
do
it
that?
is the way to think about it is to flip it on its head.
Okay.
Right now we focus a lot on a centralized entity. In fact, the very questions you're asking are based on this notion that the only way to accomplish these things is to have a central entity we trust and put all the information there, and then we trust them, and they'll release it to the right people.
My
and so
brain's
forth.
not all that flexible yet. I'm still changing the paradigm
That's
here.
right. That's right. So I can see that. The way I liken it, when you look at blockchain, you're creating a whole new place, creating a whole new city. Let's start from scratch, and we were building your credit system from scratch now.
So help me a little bit.
I'm trying to help you, but you're not letting me.
I'm ready.
So so if you're ready, the first step is you keep your data.
There is
no central.
Where am I keeping it?
I'm going to give you a system where you can keep the data. As you perform transactions, it will log the system on that page we've been talking about, and that page belongs to you.
Okay.
There is no credit agency that keeps track of it. You keep that information, and there'll be a system that's on the blockchain.
Okay.
And if you remember through the peer, it's your ledger. So you remember each peer had a ledger and a copy of the page. It's yours, so you have it. And I'll give you an interface where you can log that information, or it logs it for you, and it keeps access to that information.
Okay.
And let's say now everybody is doing that, and everybody is keeping track of those ledgers, and the chain is protecting that. If someone needs to use the information, they're going to contact you to use it, not another central third-party entity.
Right. So let me translate this for a yo-yo like me. So right now, when I buy something and somebody wants to look at my credit report, they put this form in front of me that says a lot of language that they have the right to look in my underwear and pull my credit report, and I'm signing it. And
pull it from one of three agencies that.
Another way is to tell me if I'm headed in the right direction. I have my cell phone. They give me a code, and I type something in. It gives me back a code that I send to them, which gives them access to my credit report only once for a period of time, and then when they're done, the code is expired, and they don't have access again, and goodbye.
In current day parlance, they would make the request, and then you would give them a one-time token.
Right. There we
they
go.
Can use
I didn't
the
have the
network.
language. Okay,
I'm
one-time
helping.
token.
That's my job. So, to give you a one-time token, and then you can use that token to unlock certain aspects. So they would register.
They don't even see
what
the whole
part
thing.
of my credit you want to see.
Right.
What part of my medical records do you want to see? And I'll give you the ability to see that at one time. You might have the same token system to allow them to add information to it. Hey, I just did this test, and I want to add that to your record.
For example, let's just say I have a mortgage on a house.
That's right.
I never pay them.
Right.
I don't want to give them a token to put anything, but part of the mortgages, they have the right to slip something onto my blockchain.
That's right.
If I don't pay them and I kind of give them a token in advance,
that's right.
then it's too bad for me.
And it updates the information, which is all transparent to everyone else.
Right.
And they can see that there's this issue with your mortgage, that sort of thing. The same way they can do it today in a centralized way, but it's now decentralized, and it's much more secure because of all the reasons we've talked about before. It's very hard to hack and take over your record because there's no way to get access to it.
So I have a question for you.
Sure.
Why doesn't Equifax do this? I understand. They're hacked. They're like, I see the poor CEO be testifying in front of Congress, and he's sitting there all embarrassed and people yelling at him. Why don't you just say, I give up. I'm putting it all on the blockchain. Leave me alone.
Well, Michael, you've known me for a long time. I've been in technology for over 20 years now, and that question always comes when new technology gets introduced to the world. There's always a question like, why don't we just do this? And it takes time for incumbents to think, hey, to do this, I actually have to dismantle my business. I've got to get out of the business of what I do today and do something completely different. That's hard. It's a lot easier to build a new Equifax that uses this platform than to say, Equifax, like, get rid of the fairly lucrative business that you have today even though you get hacked all the time, and do something
So
different.
sometimes it's easier to knock the house down, build a new one, than
That's
renovate.
right. That's why I always use the term new city. When I look at blockchain, it's not about replacing old systems. It's actually about creating completely new systems. If you want to replace Facebook, you create a new Facebook that resolves all the problems, and people move to that network. If you create a new credit system, and there's broad applications of this. You can look at stock trading. We've talked about this, right? If you want to, not have a centralized stock.
That's my favorite thing. I think DTC is an endangered species. You trade
That's right.
electronic stock peer
That's
to
right.
peer, and that's
and
the end of that.
there are examples of companies that de novo have launched, stock offerings that are purely digital. They produce the asset in a digital fashion on the blockchain, and there's an immutable record that you're gonna see about where the stock is, who owns it today, and there's no central party that you need to manage. Now I can keep going. My favorite is property records, especially in third world countries where people, there are millions of people out there who never, can get out of, states of poverty because they have an asset that they can't monetize in any way because they have access to a piece of land. They built these coffee shops, and as soon as it gets really big, somebody shows up and says, "Hey, that coffee shop is mine because it's on my land."
That's right.
Technically, that may or may not be true. But what if there was a way to establish provenance and build a decentralized way to manage this?
Right.
Suddenly, you would have the ability for someone to point and say, "Look, I have this asset, and I can turn that into some form of monetization."
Right. We have talked about that.
That'll raise a lot of people out of poverty. Another example is there are lots of people in African countries, for example, that participate in the global economy, and those people have a really hard time being banked. They have a huge banking system. And the reason they can't be banked is because they don't have any way of showing a true record of the transactions and the economic relationship they have with these big global brands. So what if you can put every transaction, I sold coffee to Starbucks, I sold, cassava to, a beer manufacturer, and I can put that on the blockchain. Then I can go to the bank and see, look, I've sold this type of stuff, even though, it happened. And actually, if we did that, those people would actually make more money than they do now. Because there's a lot of stealing, and the guy who comes and picks up the coffee, he says, "Well, no, I'm picking up the coffee. You only get $2 for this." Wait a second, I'm supposed to get $500. Well, I have costs. I got to charge you gasoline.
Right.
A lot of that sort of nefarious things happen. The blockchain would eliminate that. The applications of the technology is incredible because it solved those three simple problems: creating a decentralized ledger where trust is irrelevant. Right. And integrity is maintained through this.
But to me, that's very abstract. The concrete examples really helped me, and we've talked about this before. Yep. So I'm going to change gears for a second.
Okay.
What's Soluna's role in all this? Where does it fit in? Where does it fit in this whole world?
Yeah. So one weekend, I spent time with a close friend of mine, and he just went through what you went through. He asked me the whole questions. We were drinking wine. And he finally says, "Okay, I get it. Now, this kind of all makes sense to me. Crypto. So, what's Soluna's role in this?"
Yeah, I haven't heard anything related to that company yet.
Good point. So let's talk about Soluna. Soluna is a blockchain computing company. We are a company that's going to be in the business of providing a lot of the computing services that we've sort of have talked about, but not in a computing way, because we sort of created this scenario that helped to understand the technology.
Okay.
But a lot of that computation and guessing of the nonce and keeping track of the transactions on the page, that's really happening and being done by not all of the peers on the network, just a specialized set of peers that have the computing capabilities to do that. We talked about the fact that it's actually quite expensive to do all of this computation and so forth. So someone has to validate the transactions, stamp the pages with the nonce, add them to the blockchain, and maintain that blockchain. Okay. And so part of our role as a company is to create a company that does that. We're going to participate in networks where we provide the services to, manage and maintain those blockchains as a node. So we're going to be a blockchain computing company. And to be a blockchain computing company, you have to be able to have computing power.
Yes.
Right? And you have to have power. Okay.
Yes.
And so we're essentially combining those two needs, if you will, the power resource and the computing resource, into one company in a vertically integrated way.
Okay.
And by vertically integrating those two things, it gives us an incredible set of flexibilities. Number one, we can participate now because we own our own power. And by the way, we're going to own lots of power. It's on a utility scale level. It will allow us to participate in one or many networks, providing the low-level transaction validation, security, and management of the blockchain of that network. Mm-hmm. So think we can participate in Bitcoin, Ethereum, any network that we feel makes sense for us, because as we expend energy, we expect a return on that expend of energy. So we'll choose the networks that gives us that. So we'll be able to do that. And
so you're processing transactions.
Correct. We are processing transactions. So that's the first thing it affords us the ability to do.
Okay.
We're able to do it on a global scale, and we're able to do it across multiple networks. And because we own our own power, as these networks mint coin to us, right, the cost of investing and developing the infrastructure to perform that power will be lower than anyone else. And so we get very good returns on our investment, if you will.
Right, because your cost of power is amongst the lowest.
Exactly. Okay. In fact, we just to be clear, we're going to be using renewable energy, and we're going to build it all around the world, starting with Morocco, and we're going to have it's going to be based on one of the largest wind farms. It's 37,000 acres over 60 miles. Every time I say that, it boggles my mind, which affords us the ability to build anywhere around a gigawatt of power on that site. 1 gigawatt of power, which will power multiple terahashes, close to about 4 million terahashes. Okay.
Hold on a second.
Yes.
How much power is a gigawatt?
I get excited. So
what can I do with a gigawatt? Like what? Give me an example.
Somebody's going to have to fact check me, but what I like to use is think of a megawatt. Yes. Okay. So a gigawatt is 1,000 megawatts.
I buy a light bulb that's 100 watts.
Yeah. So I know. But that's not going to help you. So let's say you wanted to light a football field. That's a megawatt.
Okay. A football field's a megawatt.
That's right. Anybody can fact check
the whole
me
stadium
and write in, write it in
so
below.
This is like
whatever this is.
1,000 football fields.
There you go. That's what we're talking about. I know. That's sinking in. That's huge. I know. That's what you should be saying. So it's a tremendous amount of power. Now combine that with the amount of computing that we'll be able to power behind that. Now that affords us not only the ability to perform transactions across all these networks, but we can actually start to become, and that's our vision, is to become the foundation for all the future applications that are going to live on those networks and future networks as well. And so we can be a cryptocurrency mining company, but we can also be a blockchain computing platform company. So think Amazon Web Services, if you will, but for the blockchain. So if you're building a large private network and you need that network to have computing capacity, enough peers for it to work, we can be that peer. We can perform and become part of those networks. If you look at it as a building, and I brought this, I like Legos. I always like my little props here. So if you look at it as a building, right, you look at this thing.
Yeah.
This is the new decentralized world. I talked about the fact that everything is not replacing things, building a whole new system, okay? So if you want to build a completely decentralized framework where at the top you've got your applications and users interfacing with this, and in the middle, right, which is going to be very thick, is going to be all of the new networks we've been talking about, the Ethereums of the world. And new networks are going to form that are going to be quite large, right? Okay. For these networks to be large public networks and be trusted, they have to be secured. Okay. And for them to be secured, they're going to need low-level blockchain support and computing to provide those security and validation services. That's the role Soluna is going to play.
So why didn't Soluna just start here? I don't understand. This seems like a pretty interesting space. Why not just do this?
Well, networks are great, and you can create networks, but creating network effects is very challenging. And so while we could have created the business to create the network itself and write the code and create the network.
I mean, why not be the blockchain Facebook or the blockchain Experian, or why not do that?
First of all, there's no reason why we might not be one of those in the future.
Okay.
But I don't think it's a good place to start there. And nothing against the guys that are building applications right now. I think the space is still very young. There are a host of problems. So Satoshi solved a lot of things, but there are actually still some challenges with the technology he's built at the network level that still need to be solved over time. In fact, we're probably going to do another episode where we talk about those challenges.
Right.
So it's still very young.
I'm going to go to the, so you're saying Soluna's playing over here. There are guys writing applications over here, but there are pieces missing over here that can make it very painful for these guys to do their job. But once this is
And I've
built
learned
up.
something over the last 20 years, and so I know when's the right time.
John, this feels a little like middleware to me.
Exactly. Yeah, so it feels, I know it's the right time where to be at certain places as a new ecosystem and a new technology wave happens. What excites me is that blockchain is the next, I think, one of the next incredible waves of distributed computing.
Right.
And it's still very young from that standpoint. And so we're playing the role where we will be the sustaining existing infrastructure as the platform evolves. That's why we're starting at the low level. And my point is, there's nothing to say that we might not become part of the higher levels as we diversify our business.
Right.
But our model affords us the flexibility that we can do that in the future. So coming back, we are a vertically integrated blockchain computing company. We are going to be mining currency across different networks because we have the right power, footprint, and scale to do it.
Okay.
We're going to provide utility scale blockchain computing across the entire world. And then over time, we will expand our business to support other applications within the network. But the third piece is we're an energy company. We also can sell energy in this business. And the beauty of what we've created is we've created a new business model to create large-scale renewable energy resources that can be put to the grid. And we want to do this all around the world in places where that model is very challenging.
Okay. John, this is the first installment. I've got lists more questions. So I look forward to chatting again.
Absolutely. It's been a pleasure, Michael. Always a pleasure.
Take care.